Today we're going to take a wild ride a black hole. Buckle up, it's not exactly a comfortable experience, but it's definitely a fun one. First off, let's get some mind-bending math out of the way. Everything in the universe, from you to your camera to Mount Everest, has something called A. This is a tiny critical point. If you could somehow compress an object's mass into this super tight space, its gravity would become so intense, not even light could escape. Congratulations, you'd have yourself a black hole. Imagine shrinking Mount Everest down to less than a nanometer. Poof, black hole. Or imagine shrinking Earth to the size of a peanut. Again, black hole. But don't worry, there's no way to compress things that small. Yet. But what about stars? Big stars, like the ones way more massive than our sun, have a much larger Schwarzschild radius. When these stars run out of fuel, they collapse down into a point so dense and with such a powerful gravitational pull that not even light can escape. And that's when it forms. Now let's jump inside one. What does a black hole from the outside? Gravitational fields bend space and time. You've probably seen the weird distortion where stars seem to be in slightly different places because the sun's gravity bends the light. But when the gravity is stronger, like around a black hole, this effect goes. Light from stars or galaxies behind the black hole can be warped into strange shapes, even forming around the black hole. This is called, and it looks like a cosmic funhouse mirror. Now let's go deeper. Imagine a black hole with a galaxy millions of light years away behind it. Watch as the galaxy's light gets distorted like a funhouse mirror as it passes behind the black hole. Cool, right? What if Earth orbited a black hole? It would look. From far away, everything seems normal, but as Earth gets closer to the black hole, its gravitational field would start bending the light, creating some pretty funky visuals. The sky would distort, and the black hole would fill more and more of your view. The point where half of your view turns to darkness is where light can actually the black hole. Yeah, you could theoretically see the back of your own head if you stopped right here. Here's where things get strange. Black holes warp both space-time. For example, if someone were watching you fall into a black hole, they'd see you slow down, slower, until you seem to freeze right at the point beyond which nothing can escape. Your body would appear to fade away, redshifted until you're nothing but a dot of light. But from your perspective, you'd keep falling, blissfully unaware until, well, let's just say things get. That's the technical term for what happens when you're pulled apart by the black hole's immense gravity. The closer you get to the singularity, the stronger the pull becomes, stretching you out like pasta. First your legs, then your arms, until your entire body is pulled apart. Nothing but stretched atoms. After that, well, your fate's anyone's guess. If the black hole is big enough, you might get to the event horizon and feel relatively comfortable for a while. But the end result? Not so much. Here's an exciting twist. Some scientists think that spinning black holes could create shortcuts through space that could, in theory, let you travel faster than light. But don't get your hopes up just yet. This is still. No one's hopped through a wormhole yet. An acoustic black hole? But we experiment with black hole-like physics in labs. Enter This is an acoustic black hole that traps sound instead of light. It's not as powerful as a real black hole, but it's helping scientists understand the laws of physics in extreme conditions. It's kind of like playing with a sound version of a black hole in a lab. What would it be like to travel at the speed of light? Now let's throw in something wild. If you could travel at the speed of light toward the sun, you wouldn't just see it rush toward you. No, instead you'd see it appear to from you at first. Why? Because at light speed, your field of view stretches out and you begin to catch light from behind you too. As you get closer to the sun, everything would concentrate in the center of your view. Mind-bending, right? Where's the center of the universe? Here's another brainbuster. Where's the center of the universe? Well, thanks to no matter where you are in the universe, it'll seem like everything else is moving away from you at the same rate. It's like the surface of an inflating balloon. No matter where you are, you're always at the center of expansion. Neat, huh? A Googleplex-sized universe? And finally, let's imagine a universe that's a googolplex meters across. That's a 1 followed by a googol of zeros. If the universe were that vast, statistically, there's a good chance you'd have an of yourself somewhere else out there. Now a crazy thought. If this blew your mind, check out Brady Haran's for more mind-bending math and science. It's full of amazing geeky goodness. And if you love numbers, you'll want to subscribe. Thanks for tuning in, and remember, wherever you are in the universe, you're scientifically